Okay, there we go. There we go. Hey everybody, good afternoon. How's your reInvent going? Everybody still having fun, you know, learning new things, yeah, those type of things? That's great. So thank you very much for coming out and spending your afternoon with us. I know there's a large catalog of places you could have gone to and to sessions you could have gone to, so we are very humbled and thankful that you chose us. Hopefully we'll teach you something new that you haven't known, and we'll tell you a little bit more about what we're doing together with Red Hat and OpenShift. To just do some quick introductions, my name is Mandis Momberg. I am a Principal Solutions Architect, and don't let the accent fool you. I generally just pretend to know about things. I don't always know about things. I'm joined here with two of my colleagues from Red Hat that work very closely with us from Amazon Web Services, and this is Nicholas. Nicholas, would you introduce yourself quickly?
Nicholas Dross-Matos. I work in the Emerging Technologies division at Red Hat, so basically I'm a nerd that gets to play with cool stuff.
And I am Brian Tanis. I'm a technical marketing manager for OpenShift.
Great, yeah, so that's who we are. We work with customers very frequently on all of the problems that they're trying to solve with the container platform Kubernetes, but specifically the OpenShift container platform. And we've basically taken all of the things that we've learned from what our customers are doing and our joint customers are doing and distilled it into a little bit of a message that we'll talk about today. And that message specifically is how to get SaaSy with OpenShift, right, on AWS. So there's so many things to consider when you're adopting a modernized workflow. A modernized workflow is really that thing that you're trying to achieve when you say and talk about things like elasticity, scalability, availability, and agility. Apart from obviously winning every word bingo game out there by saying those words, it really does mean a lot to our customers. Having elasticity and being able to only pay for the infrastructure that you're really using and saving money on those things to invest in things like R&D and the development of your application is really one of the core tenets of success for our customers. And container technologies has made that a lot easier to do. Couple that with the Amazon EC2 services and the other managed services that we provide in AWS, and it really maximizes your ability to focus on the value of your product and your business rather than on things like infrastructure and the over-provisioning and management of services. Agility is truly the magic bullet. It is that magic clay that puts everything together and keeps everything together. We say that because if a customer of yours is trying to access your website and they find a bug or they find something broken on that website, they're not really going to wait around for you for a long time to fix that problem or to release a new feature. They'll most likely just jump over to another product owner that already has that feature or that availability. So agility is that ability to listen to your customers when they tell you that they want a new feature, they want something fixed, they want a different experience, and for you to be able to deliver that experience in a very short period of time. So agility is really, really important. And again, container technologies, especially with the way if you connect it with things like automation, security integration, and doing it the right way, get you to that point where you can conceptualize a new idea, a new feature, and get it into production in a couple of hours or days instead of weeks and months in the traditional capabilities. Now, availability is again one of those tacit things where if your customer tries to access your application and it's down, they're not going to wait around. So together with something like AWS and our multiple availability zones and all of our international regions around the world, you can guarantee an almost always up time for your customers when you deploy your containers onto AWS. So with containerization and the advent of microservices, we have this idea of shifting to the left. And what does shifting to the left mean? Shifting to the left basically means give your developers, the people that are actually building the product, the people that are actually building the experience for a customer, the responsibility of the experience in production as well. It's no longer that circumstance where the developer writes the code in his own test environment, throws it over this wall to the operations teams and to the security teams, and then that experience completely changes to what the developers and the product owners envisioned. They want to now actually own that experience in production as well. And that really becomes a core part of success in the new world and in the new digital transformation era. Because if the developers now also own the experience in production and they have the freedom to innovate and iterate on their products based on direct feedback from their customers, they actually become more successful. We have this really interesting data that shows us the more responsibility we give to our developers for the experience in production, the higher the quality of code they write. And the reason we found for that was because no developer wants to be paged at 3 a.m. in the morning because of bad code or something in the application failing because of bad code. So shifting to the left, giving the developer more responsibility, more ownership of the experience the customer has, and also being able to develop microservices that detaches and breaks down these applications that they used to have into microservices, allow them to focus and elastically scale independent portions of these applications. At Amazon Web Services and Amazon, we have this concept of something called a two-pizza team. The moment that the team grows beyond the point where 2 large pizzas can feed that team, it means that there are too many people in that team. So we break it out and we give that responsibility or an irresponsibility of focus to that smaller team. And that's where microservices really come into play. And as you take and break down that monolith, you become more successful. We went through this breaking down the monolith process at Amazon, where we broke down a 2.4 gigabit monolithic application written in Java down into thousands of microservices over the course of a couple of years. And the result is obviously what you know today as Amazon Web Services. Now, that is a very, very difficult experience to do if you have to do it the way we did it. We did it the difficult way. We needed to come up with new ideas. We needed to figure out all the technology on our own. But with partners like Red Hat and with platforms like Red Hat OpenShift, it becomes a lot easier. The S2I technology, for example, allows you to take existing applications and containerize them with almost no effort and no changes in the code base that you have. And that already puts you into that 2 portions of elasticity and availability and gives you that iteration capability. So now you can start breaking down that monolith and having your developers break out that monolith into some more microservices. Integrated into that platform is a very prescriptive, a very opinionated way of doing security. The pipelining and automation for making sure that your applications are going through all of the right correct checks so that you do have PCI compliance, that your applications aren't exposing CVE bugs or doing the wrong things in your application stack. So OpenShift integrates that with ease into your application platform. And then a unified admin experience, where the developer that's got the operational experience responsibility and the administrator that actually administers the infrastructure the application runs on share a common view. They can track the same things, they speak the same language, and neither has to go for extensive training to learn a new language to understand all of these things. So if you look at a very high level of what the environment could look like for a modernized environment using containers, you'd look at something like this, where you have an enterprise-grade host OS running on your infrastructure, whether that's an EC2 instance or on your on-premises environment at the data center, and you're running something like CoreOS or Red Hat Enterprise Linux. And on top of that, you have all of your infrastructure and automation projects of how to deploy and set up and configure those hosts. Then you have SDN, software-defined networking, that will allow you to do things like compliance. And Calico, for example, to use that as policy-based routing. So now you can have multiple application teams deploying into the same infrastructure, but those applications will not interact with each other. Or you can securely make sure that they do not interact with each other if they shouldn't. And you can do reporting on that. If you have a rogue, for example, a rogue application deployed onto the cluster, you can track it, isolate it, and expunge it from the cluster very easily. Then you have the container orchestration that is managed for you by Kubernetes, and Kubernetes obviously being the de facto standard of container placement today. Yep. Application lifecycle management and CI/CD, all of that integrated in an out-of-the-box experience with AWS and OpenShift Container Platform. So you can go to our quick starts today and you can deploy this and have automation, security, build automation, all of those things integrated out of the box and ready within less than an hour when you use OpenShift Container Platform on AWS. Right. So now that you have this platform, is that enough? Is that enough to just enable that for your customers or to have your developers take more ownership? The truth is no. A very big part of success when dealing with containers and modernizing your business means that you have to make a significant investment in a cultural shift. And what does that mean? That means that these two-pizza teams, these smaller isolated teams, need to be able to work together in parallel almost in the same way as a multi-lane highway where you have cars riding on the road without them actually bumping into each other and causing friction for each other. And the way to do that is through implementing a set of road rules, a set of guidance and wireframes that these teams need to adhere to, but without constricting them. They can still choose their own model and make of car, right? Their language of choice. One could be Rust, one could be CLang, it could be different tool sets. But they still have to adhere to things like speed limits or the way that they deploy their tools and the pipelines that they use. And that's where OpenShift Container Platform really shines through, because those governed rules that you would want to implement and influence your developers with and your teams with comes preloaded out of the box as a standard implementation in OCP, or the OpenShift Container Platform. So Nick is going to talk to us a little bit about how you can take those rules and those guidelines in this OpenShift Container Platform and use other native services like the AWS Service Broker that we developed jointly with AWS, and how you can use services like Amazon RDS with the OCP platform.
Yeah, and we have a really cool demo that we're going to walk through as well that Manus is going to talk about. But who here is familiar with the service brokers that we have with integration with OpenShift and AWS? Okay. So, will you go to the next slide? Getting the service broker installed is actually incredibly easy. If you already have an OpenShift cluster that's up and running, it's really just a few commands. You can actually just do wget, pull it down, and actually essentially just run the script, and you can do the full configuration. Full instructions are actually located at that URL. Incredibly simple, and then it just authenticates using IAM. If you want to do it in a development environment, so maybe you're not running OpenShift in AWS or within your own individual infrastructure or hybrid cloud or wherever you're running it. Maybe you're just doing it on your own laptop. You want to kick the tires. You want to get a little bit used to OpenShift before you actually start running it in production or at scale. You can actually do the same thing using OC Cluster Up on your own individual laptop. So you can deploy an OpenShift cluster plus the AWS broker just in a few commands. Basically just git clone that repo and then actually run. And from there you can actually start getting hands-on experience with it. And again, at the bottom, there's the GitHub link so that you could go take a look at that for yourself. And then last but not least, some might be familiar, some may not, but Red Hat has been working with AWS on actually leveraging a combination of Ansible and the CloudFormation scripts to do a full deployment of OpenShift in AWS. Very simplified, very easy, goes through and asks a series of about 25 questions or so. You pick region, availability zones, you specify certain parameters such as the nodes, your Red Hat service or Red Hat subscription info, pool ID and such, and it'll actually go and build out that entire OpenShift cluster. And actually one of the options that you have in there, which there are a number of options, is deploying the service broker as well. If you haven't taken a look at that, I highly encourage you taking a look at the quick start. The link is at the bottom. And if you're looking at running OpenShift on AWS and you want to kind of do an evaluation or a proof of concept on it, reach out to us, grab us at the booth, and we'd be more than happy to actually give you credits, so evaluation credits both for AWS and evaluation subscriptions for OpenShift. So why does the OpenShift service broker, why does it even really matter, right? What's the whole point of it? Well, typically, this is how a lot of our customers are deploying things today. There's a lot of steps. A lot of them are manual. They go into the OpenShift Service Catalog. They create an application. From there, they go into the AWS Web Console. They provision whatever AWS services specifically that they need. Then they have to go up and configure all the IAM stuff. Then they have to tie the two things together, copy the AWS keys into the OpenShift secrets, and then associate the newly created secrets with the OpenShift application, right? It's a lot of heavy lifting. It's a lot of work. And if you're thinking about doing this where you're constantly spinning up and spinning down, infrastructure or deploying new applications and such, really it becomes complicated and convoluted because now you're getting a combination of your developers and your operations teams both having to do this menial task on a pretty consistent basis. And on top of it, who provides support, right? If something breaks, is the developer's fault that he needs to troubleshoot it? Is the operations fault that needs to troubleshoot it? A lot of infrastructure or a lot of companies don't want to actually, their operations teams don't want to give access to the developers to go log into the EC2 console or the AWS console, right? So the idea is that with the service broker, being able to authenticate and actually you being able to control those policies and such for each of these individual users, they can actually, from the Service Broker, go into the service catalog, create an OpenShift application. Maybe they want to deploy a Spring application, Java. It doesn't really matter. They can then select an AWS service, and then they can actually bind those two services together without ever leaving OpenShift. Everything happens all on the back end seamlessly. So it kind of would look like this, for example. Developer goes in, says, hey, I want to deploy WordPress. I know it's a very simple application, but that's just what we're going to show. They select the AWS services, and then from there, they actually go through, and they basically say, I want to bind those credentials. They say, create secret and WordPress high availability to be used later. It actually binds that, or you could choose to not. And it'll actually bind all of this together. And we're going to actually show some of this in the demo itself.
Yeah. So Nick, this whole process of deploying AWS services, is there a specific way that we deploy those services in AWS using OpenShift Red Hat?
Well, I mean, it really depends, right? I mean,
right. I mean, so the reason I'm asking is I know that a lot of our customers say that they want best practice deployments when they deploy things like RDS.
Of course.
So how do we know that that RDS instance that I'm going to provision through the OpenShift platform actually adheres to the standards that I want?
Operations teams set all of those different values and those parameters, and they pass those parameters on directly to the developers. Those developers can then select or choose from those parameters. So for example, if you want a production-ready RDS instance, you select the production-ready RDS instance. There's variables that you could pipe into that. Or if you want a development one, maybe it doesn't have the same level of high availability or performance or whatever you want to consider it to be, you could limit to them that as well.
Okay. So an operations engineer can take our service broker and they can modify the templates and maybe make changes to those basic templates as well?
Absolutely.
Okay, that's cool. Well, so we did a recording of a demo because the demo gods are never good for us at reInvent. Like, it never works and the Wi-Fi always fails. So we did a quick recording where we used the OpenShift container platform together with a collection of AWS services. These services are S3, SQS, SNS, SES, to build an application that takes data that's stored from S3, runs some machine learning processes on it, and then gives us recommendations on groupings of stocks that you probably should be interested in, right? So let's quickly get that started. That's just the recording. It's pretty simple. Oh, we need to flip the...
And then spacebar.
It's not on the screen for some reason.
Oh, yeah.
Oh. See, this is why we record demos instead of doing them live, because even the video play was always fast. Okay, so here we are inside of the OpenShift console, and we created a new application, and it's a pretty simple application, and we provisioned some AWS resources as well. As you can see, we have S3 there, we've got SNS there. Who is not familiar with those acronyms that I just threw out there by a show of hands? Who doesn't know any of them? Right? Well, okay, so these are very useful services, and you can see that we've deployed our application in a container, and right now it says that it doesn't have the credentials to connect to those services that we want to use. And that is the process of binding, where the OpenShift control platform actually reaches out to AWS, gets the credentials and the security credentials that are required, and automatically provisions that and gives that to the containers. So your developers and your operations engineers never need to go into the AWS console to manually set up anything like that, or the developers don't need to actually code those credentials into their applications either. So at this point, we have now bound those services and those applications to our containers. And if we go and refresh it in just a second, then you'll see that it now has connectivity to all of those Amazon services that we want to do. It's important to know and to understand that none of this was done beforehand. All of this was done by the container platform, and then you can see the container actually relaunching and now binding all of those credentials. And if we reload the page now, you can see that those errors are gone, and now we can see the whole machine learning on public stocks. So what we're going to do is we're going to select a data set. We just used one of the public data sets that's available on AWS in S3. And we're going to ask it to analyze a block of stats for us over a certain period of time. And it's going to go and churn away at the back using some containers that it's going to pull data from AWS. It's going to do the machine learning. And once it has a prediction for us, it's going to submit a message to SQS. And that SQS message is then going to send us an email using SNS and SES to let us know that the predictions have been done. Once that prediction has been done, it'll generate a little graph. upload that graph into S3, and then we'll be able to visualize all the stocks and the grouping of the stocks that it gave to us. Please, just by the way, you should not be taking any ideas from the stocks. This is just some random machine learning algorithm that we stuck in there.
I'll be right back. I need to call my broker.
Yeah, just don't go buying stocks based on these recommendations. So there you can see our clustering. It's now polling our SQS. It's basically looking at all of the historical data. And we can submit multiple jobs. Every time we click to add a job, you'll see a notification pop up that it actually received a new job. And it'll automatically scale out these jobs across containers in the OpenShift platform. It automatically will, based on demand, scale out and add capacity to make sure that it comes out in a timely manner for your analysts. Because imagine you have a set of analysts that might want to visualize this data or use this data, right? So there we can see we've got some clusters of data that came through there. We now know that some of these stocks have been clustered together. And we basically want to see if we have a notification in our email now. So we should actually see our email pop up and say that we have a notification. There you can see AWS notifications through the SNS service. It has the raw data for us there. But it also has a link of a graphical output that we generated and uploaded to S3. So if we open that up in just a second, there's an interesting cluster. Obviously, it put things like Wells Fargo, General Electric, JP Morgan Chase. I'm not sure why it thought all those things deserve to be in the same cluster, but it does. And here you can see us opening up the actual visualization that we uploaded to S3. So you can now just use that visualization if you need to do reporting or those type of things. But that's pretty much it. It took us about an hour and a half to come up with this application, to work together and deploy all of these services in AWS. The OpenShift control platform or container platform did everything for us. We never needed to open the AWS console ever. The moment that OCP was available for us to use in our AWS account, it automatically provisioned the AWS services, set up the IAM credentials and security, attached it to our pods inside of the platform. It assigned it to scaling pods as it scaled out, as we stress tested it. SES, SENS, domain management, all of that was done for us by the OCP platform. And we never actually needed to manually interface with the AWS IAM or AWS CLI at all. So that is the AWS Service Broker, and we're very excited to announce that we are extending that cooperation with Red Hat as well in an introduction of something we call the AWS Operator. And the AWS Operator fits into some exciting things that Red Hat is doing with the upcoming versions of OpenShift as well. So I'm going to leave it again to my friends at Red Hat to tell you more about what 3.11 looks like and what we might see in some later versions of OpenShift.
So before we begin, I kind of have a question. Who all here is using containers already? I would assume quite a bit. Yeah. OK, cool. What about Kubernetes? Yeah, still quite a bit. Who all has used OpenShift? Maybe not necessarily in AWS, but OpenShift. All right, cool. Yeah, that's nice. That's nice. OK, so what about 3.11? There was quite a bit. Who all has used 3.11 for OpenShift? Smallest subset. OK, awesome. So this is going to be awesome. So I'm going to talk about what's new in OpenShift 3.11. So what differences have you seen? So the first aspect here, once you go spin up OpenShift, log into the web UI, this is going to be the very first thing that you're going to notice that has changed. So we now have new admin-facing consoles that are able to, you're able to use them depending on who you are. So if you have maybe an app dev person that's administering parts of the cluster, they could get a particular application view. If you have somebody that's maybe handling infrastructure, they have a cluster view that they're able to see. So the new admin-facing console is quite robust. There's a few different changes, and you could see with 3.11, we're changing a little bit of how we're doing the UI in OpenShift. The next aspect would be visibility into nodes. So previously, you're able to go log in, and you're able to see applications, and you're able to see what's going on in the cluster, but you might not be able to see specifically what's happening in the nodes as part of the web UI. So in here, now you're able to go dig in. You could see specific resource utilization for the particular nodes that your cluster's running on and your workloads are running on. You could see things like memory, CPU, those basic aspects, but you could dig a bit more into it so you could troubleshoot a bit more with the latest version of OpenShift.
I've always found it interesting. I mean, a lot of these metrics and things that are collected and inspection of nodes into things like Kubernetes clusters are always open state and readable to the world. Is there something that OpenShift is doing to make it a little bit more secure so that people can't just read it if they don't have access to it?
Yeah, definitely. So we're getting into that. So OpenShift makes RBAC, so role-based access control, quite a bit easy to use in the cluster, right? Some of that's part of generic Kubernetes, but we make it so that you're able to get that fine-grained security context and you're able to determine, hey, this person should have access here, or this particular logging might, have a particular lockdown so that, particular users can't see what's going on as part of the cluster. Part of 3.11, again, access control management, right? So we're able to now set and configure some of this stuff using the OpenShift cluster, or the web UI, sorry. You used to be able to, go in through the CLI and handle configuration for role-based access control. Now you could go through and set some of that stuff using the web console. So if you need to make a quick switch or add a user or whatnot, you could do that in the console now. You're also able to further troubleshoot a bit more using cluster-wide event streams. So you're able to see everything that's going on in a cluster in a really easy, simple to use view. So whenever you spin up an application or a workload, maybe something's not working or maybe something broke or what have you, OpenShift usually should handle that, but sometimes there are issues. You're able to see what's happening here in one easy to use view, right? So it makes troubleshooting quite a bit easier. You just go to this cluster-wide event stream, and you could see everything that's happening in the cluster, and dig in and see what's going on, and figure out what you need to troubleshoot.
I'm also interested in, could I be able to use this event stream in a non-UI fashion to event on things? For example, if I detect a certain event happening in the stream that I could action or remediate automatically, like a pod failure or something like that?
Yeah, so all these features and functionalities aren't just part of the web UI. These are highlighting some of the things that are brought to the web UI, but you're also able to get a lot of this through the console, through the OC command and whatnot. The biggest aspect, at least in my perspective, and quite a few Red Hatters, I would assume, is the operator SDK. So adding operators into OpenShift, right? So now we're able to handle that. Operators are a big aspect. Mandis already talked a little bit about how Amazon's working on that, and working on some of the operator aspects. What operators do, it's part of 3.11 now. It's going to be heavily involved in future versions of OpenShift. But the operator SDK and operators allow you to provision workloads in your OpenShift cluster, and the operator handles all of the hard, heavyweight tasks that you would have to do. So the example would be Couchbase. So you have Couchbase, you could go and add that so that you could provision that and use it within your applications, right? So you could do that now, right? With previous versions of OpenShift. But with 3.11, you're able to use the operator from Couchbase that knows how to install and set up Couchbase in that cluster before, you might run some YAML commands and whatnot and get that integrated in. Now the operator is able to handle setting up, doing all of that, and then it also handles upgrading tasks, right? So if, say, Couchbase updates, instead of having to rip and replace Couchbase instance and whatnot, you could go in, use the operator, and it'll automatically update. Builds in Jenkins also have been updated for better performance. So we're using a more recent version of Jenkins to provide better stability and better performance for your CI/CD workload. So OpenShift is able to handle CI/CD within your environment. So if you have a developer that's pushing source code to a repository, a webhook could fire, and it'll automatically set off a build using CI/CD, using Jenkins. So with 3.11, we're having updated versions of Jenkins for better performance and resiliency and whatnot.
My personal favorite.
Well, CI/CD is important. Oh, this one, yeah. So the cloud, this is an AWS specific feature that we're supporting now. And with 3.11 and OpenShift, we support auto-scaling groups. So if your cluster has workloads that need to be scheduled, you don't have enough worker nodes to be able to handle those scheduled tasks or those pods to turn up and turn down, auto-scaling now could go and provision more nodes for you automatically on the fly so that your cluster could burst if it needs to. It also is able to detect and see that, oh, hey, look, we're not using those resources anymore. Black Friday is over. We don't need all those nodes. So it could go and turn down more nodes so that you could have your cluster a bit more efficient, right? So auto-scaling, AWS-specific feature, part of 3.11 as well.
Yeah, and we're pretty proud of that collaboration as well. It's one of the things that we really work together with the Kubernetes community, and where we really invested a lot of time and effort in understanding how the metric server works, working with the horizontal pod autoscaler, and making sure that that also translates very well to the physical infrastructure and launching EC2 through secure autoscaling groups and launch plans. And what's nice about this, which is really powerful about this, is that you can prime your autoscaling group with images, right? With golden images, with security images, with all of the things, and preloaded containers of tasks and those type of things. So you could really get that point of scaling to having a new node available with the daemon sets and everything that you want on it for maybe monitoring or for network traffic in seconds, because that image is just always available, and your scaling and elasticity really grows. And as I said earlier, that elasticity is one of the core factors, and that availability is one of the core factors that we see in successful companies that have modernized, companies like Liberty Mutual, companies like Cathay Pacific, or the Schiphol Airport that we worked very closely with the OpenShift platform.
Just randomly wondering, who's been waiting for this to be available in OpenShift?
There we go. Autoscaling was probably the #1 ask for us for probably 6 months, right? Almost closer to a year, really.
I was thinking like 2 years.
Yeah.
All right, so I personally come from a networking background, and the router enhancements are pretty important as well. So now we're supporting updated features and functionalities using the router. The router is the ability to allow us to access resources and applications and workloads that are running on OpenShift externally, right? And it handles all the networking under the hood. So the router does quite a bit. And now we're able to provide HTTP2. That's very important, right? So provide applications in the modern web, you need to have HTTP2, that's important. Performance, as far as the router goes, now we're able to add additional threads so that the router is able to handle more heavy workloads, right? It's able to do quite a bit more. We'd have dynamic changes without having to reload, or we can reload the configuration in the router instead of having to completely rip and replace that whenever we make a change if we need to, right? And then we're supporting SSL and TLS updates there. So say you have a client that's accessing your application and they maybe don't support SNI certificates. Well, now we could handle that using MTLS, and we're also supporting some updating logging there so that we're able to pass some of this logging to operators and things in the clusters so that you're able to see what's going on from the network aspect. A couple more aspects here. So security. Again, focusing a little bit more, networking touched on it a bit, but in security aspects, we have something called security context constraints. So security context constraints and pod security policies, they allow you to set fine-grained constraints on your particular applications or pods that are coming on in the cluster. So one of the examples would be, let's not allow this particular pod or application to have host networking, right? You don't want to do that. So you could set that so that that does not allow it. It won't be able to happen. You can make it so that the file system of that particular container is read-only. Things like that. There are quite a bit of security aspects here, and like I said, it's very robust. There's a lot of fine-grained details and knobs that you could change here to provide better security for your application.
Yeah, who in the room constantly struggles with questions from your security teams around things like PCI compliance, things like FedRAMP compliance, those type of things? Just a quick hand, right? These are really powerful for those type of workloads, and we see a lot of our financial sector and our government sectors applying these type of things where they're almost deployed as a templated system, right? Remember those guardrails and those road rules that we were speaking about? These apply to that. So you could essentially build an application and have a developer build an application and apply these rules to it, and automatically the platform takes care of it and be in full compliance of your workload. These answer so many questions around security, the security security model inside of containers, the orchestration and the networking layer and all of those type of things. And again, it is a very opinionated view, so you don't have to go and download a bunch of open source tools and do this manually on your own. This is all available out of the box in OpenShift, and you just use the feature that's available.
This is an extremely good point. It's all built into OpenShift. It makes it easy so that you could work and finely tune that security policy depending on what you guys need. So there are a couple of other things that we're going to talk about, so monitoring and logging. So now Prometheus, which we had a little bit with that before with 3.11, but now Prometheus is coming GA. So it's available, it's there, and Prometheus really allows you to get quite a bit awesome monitoring of what's going on in your cluster, right? You could get pretty detailed insights of what exactly is happening on the node level, what's happening in the cluster, what's happening in each individual pod, right? And you could see that using Prometheus now.
And I'll be showing that after.
Yeah, that's a good point. So after I talk this last slide, we're going to go through and talk a little bit about the updated features of 3.11, so you'll be able to see the new console, Prometheus, things like that. Logging as well. So now we have Elasticsearch 5, Kibana 5, so we're able to provide better resiliency for our monitoring stack that we do have, or the logging stack, and we're also able to do it with less resources that you need, using better performance and whatnot. So we've done quite a bit there as far as logging goes. So now I'll hand it over back to Nick so that we could go through a demo.
Yeah, this time we're actually trying to do the demo live, so I mean,
see how it goes.
So those that are familiar with OpenShift, this looks no different than anything else probably you've ever seen. Typically, you go through and you actually select an application, right? So you have your application console, and from in here, you can actually take a look and see, your different pods and the status of them, what they're actually doing, taking a look at the deployments and such.
Yeah, so at this point, it seems very familiar, right, Nick? I mean,
totally familiar.
This seems like 3.7 all the way up to 3.10.
Yep. Right? And then we start getting into the cluster console, and this is where things diverge dramatically. So you have your configuration of your operators, your workloads, your networking, your storage, your builds, and such. So as we were alluding to with monitoring, well, let's start there. We actually have these really awesome dashboards that have been integrated. So if you wanted to actually take a look at the resources in your cluster, I can actually take a look at the CPU utilization, the commitment. I can actually see memory utilization and what's actually consuming all of this. I can actually go back if I want, and I can take a look at this from a pod perspective, and I can see what my pods are actually doing as well. So I can see my memory utilization, my CPU utilization, things along those lines. So this is really great. You can actually select by each individual node. So get all the information you're looking at, whether it's disk I/O, network utilization. Typically, you would have to either integrate some type of third-party solution into this, but this is all pre-baked into OpenShift. This is all part of the standard deployment and part of the standard installation. So therefore, whenever you're doing upgrades of OpenShift, it's guaranteed that the next iteration is going to work. You're not going to have to worry about backwards compatibility. Is my version of Prometheus or Elasticsearch and so on and so forth going to actually work appropriately?
So Nick, how long did it take you to deploy the cluster that you're working on right now?
About 2 hours total.
2 hours total. Was that using the AWS Quick Start? Was it a self-deployment?
AWS Quick Start.
Okay. So what do you need in order to deploy using the AWS Quick Start and get to this point where you can run the application?
Obviously, you need an AWS account.
Sure.
And then you need to actually have the OpenShift subscriptions. So you could either have trial subscriptions, which you could request from us through the portal, or if you have subscriptions that you've already purchased, you just migrate them over via cloud access.
Okay. Do you maybe have, can you pull up like the quick start quickly and show us how that looks like, what that looks like to launch the cluster? We spent a rough amount of time together, building out this quick start. Nick initially built the architectural reference guide for what OpenShift should look like on AWS in a high availability fashion. So there you can see the architecture that we talk about. So if you look at the architecture of how we deploy OpenShift on AWS, it is a very highly available deployment. So we make sure, it's gone now, Nick.
I'm sorry.
Click on the what are your builds. Yeah, there we go. So if you look at the architecture diagram, you can actually see that we deploy it into 3 different availability zones. Now, I'm assuming most people here know what an availability zone is, right? It's our way of discerning different areas of high availability in AWS. So we deploy 3 masters in 3 availability zones. We also deploy 3 sets of routers that we've learned about now into different availability zones. And we all deploy them into auto-scaling groups to auto-heal in case of failure. We then pre-populate that with NAT gateways for security so that the nodes aren't accessed or accessible directly through the internet. And we front all of the applications and the application routers with AWS application load balancers and classic load balancers. So basically in this configuration, you can independently scale up multiple tiers of your application in the containers and also make sure that if in any case an availability zone in AWS goes down, it won't affect your ability to deliver your customer solutions. And with our auto-scaling solutions that are native and integrated into OpenShift, that's actually even done better because you can do things like EBS scaling and those type of things with the applications as you deploy them in different availability zones.
And also container native storage is integrated into it directly as well. So if you're looking at highly distributed persistent storage that's scalable, that's also an option that you could select.
Exactly, right. So that's what you get when you run the quick start. If you had to go and do that manually and run that on your own, it'll take you a couple of hours, maybe even a day or so. But for us to deploy a quick start is pretty easy. You go to this page that Nick just quickly pulled up, and you click on the option to either deploy it into a new VPC if you want to create a new VPC, or if you have an existing VPC in AWS that you want to deploy that platform into, you can just click on the link that says deploy into your existing VPC, right?
Yep.
And that opens up a form that you fill in, basically just a bunch of input fields, and that's where you type in your licensing keys and your pool numbers and those type of things.
Yeah, and we have the deployment guide right here at the bottom as well, and also, as I mentioned previously, you could request AWS credits for the deployment on this page as well.
Yeah.
So if you're looking for AWS credits for a POC, we're more than happy to actually help accommodate that.
Yeah. So who of you have heard about the container competency that was launched at reInvent this week? Great. So we're also excited to say that OpenShift and Red Hat is one of our competency partners, launch partners. So I don't know if you know this, Nick, but congratulations if you didn't. Red Hat is part of the competency, which means that we will be doing POCs, and there are POC credits and those type of things for container workloads are running on OpenShift container platform on AWS. So all of the benefits that you can get as part of the competency, the container competency, those benefits apply to the OpenShift platform as well.
Yep. Now, there's one other thing I did want to talk a little bit about, which was a case study. And if you go to our booth, you can actually pick up the hard copy of it. So I'm just going to kind of glaze over a little bit of it. But we had a Fortune 10 financial services company, and they were looking at actually implementing a container solution. And they were looking at their first phase of the implementation being 10,000 vCPUs. That's phase 1. And they were looking at, as part of this implementation, taking their MVP products and actually getting those containerized, the easy low-hanging fruit, and moving those over into AWS. And they were actually going to deploy this long-term in a hybrid type of manner. So currently they're running OpenShift in their own data center. They wanted to move a lot of this stuff into AWS, and later on they were looking at possibly moving to other public cloud providers as well, so that they would have a multi-cloud or a poly-cloud deployment. The second and third phases of this, they were actually looking at over 100,000 vCPUs, which is probably one of the largest deployments that I've seen of any type of containerization platform. And the big thing that led them to OpenShift was managing that type of infrastructure at that type of scale and having to take a lot, because if you look at Kubernetes is a project, right? It's not a product. If you look at all the other components that you can actually go and pull off the shelf that are open source or whatever, and you want to integrate together, how are you going to actually validate that all of those components and those pieces, those runtimes, and the operating system are all going to play well together, right? It might when you first deploy it, but 6 months, you get drift. 12 months, you get even more drift. People leave the company, documentation changes. What about container runtimes changing, right? People are looking at like CRIO and things along those lines. It was really important to them to actually have the stability of knowing that they could pick up the phone, they could call AWS or they could call Red Hat, and they can get the support for this type of infrastructure. And this case study is really, really fantastic. It goes through all the different phases that they went through, the applications that they initially chose, how they actually went through the process of implementing them. It's really, really great. If you're looking at deploying a container platform and you're looking at doing something that's production ready and verified, maybe you're working in the office of the CIO or CTO, I highly recommend taking a look at this because it would make your life much, much, much more simple as far as seeing all the different trials and tribulations that they had to deal with, whether it came to security and compliancy, to designing for scale. I mean, it's roughly, I think, around like 12 or 14 pages long. I would have loved to hand it out, but unfortunately, I didn't have time to go to FedEx to go get all of these printed up, so they'll all be at the booth.
Yeah, so let's put that in scale, or just put it in context a little bit. What was it 100,000 vCPUs?
100,000.
What would 100,000 vCPUs look if you had to build your own racks? Like, how many racks would that be? How many operations engineers would that be? Just off the top of your head, if you had to think about this.
A lot.
A lot, right? And ultimately, I think the operations team for that company turned out to be, or now that's managing the system, is I think something like 5 engineers that's running the system, right? On
And the most interesting thing was when they were looking at implementing it, they were wanting to do obviously more with less.
Yeah,
right?
Exactly.
And they wanted to actually also increase their productivity and increase the getting their minimum viable products out the door as quickly as possible, which was like, it's like, well, you want to do more with less, and you're doing it at this scale, and you want to shift. There's a lot of moving parts. There's a lot of different things. Yeah. The crazy thing to me is that they did it over these 8 different phases over a 16-week period.
Yeah, that's an extremely short runtime, right? I mean, so here we have a company that's deploying on hundreds of thousands of vCPUs. They're modernizing their business as they go along. They now have agility. They have scalability. They have elasticity. They did it in 6 weeks, 6 weeks. 16 weeks, sorry. 16 weeks. They're doing it with a very lean team, a 2-pizza team. And how many headaches did they run into? Like, how difficult did they find it?
That's what was most interesting. They didn't really struggle too much with it at all.
Right. Yeah, because OpenShift became that guiding light, that prescriptive guidance for them. So it is a great read. I really enjoyed reading through it, and I would really suggest going to the Red Hat booth and picking up that white paper to read through it. So we have about 2 minutes left before we have to start asking or opening up the floor for questions. I'd like to quickly just point out something. As a developer, one of my favorite things in OpenShift is build configs and being able to do templating around applications. Now, with containers, it's also really fun because a lot of teams always consume different stacks, right? Like I might have an Nginx stack that will plug into my container as a layer for my application, those type of things. And build configs in OpenShift has really made that very easy because I could store these build configs as a templating engine inside of OpenShift, and different teams using RBAC, obviously, can access these and use them as templates to create images and pull from Git resources and ingest that into basically the application that ultimately delivers the experience to the customer. And that's all integrated into the automation pipelines, and Jenkins then obviously facilitates those builds and those type of things. So it's one of those features that have saved me a lot of time personally. And with this new admin platform, you have that centralized version or that centralized view where you can look at all these build configs and can do analysis against them. You can actually make sure that you do inspection through making sure that they comply to your guidance and also to your rule sets and all those rules that you have to implement.
Yeah, and I think the great thing about having this operator/operations dashboard is you can actually see all the different namespaces as well in multiple different projects. So from an operations standpoint, it's no longer having to hunt and pick and try and figure out. Same with like when it comes to like logging, for example, you can actually just go through, and let me pull this up real quick, like for metrics and such. I can actually just go through and I can actually specify the metrics parameters that I want, whatever the expression is, right? And I can go through and I can dig and pull all this information out. Whereas previously is a little bit more complicated, or you were piping all of this out to like some type of, like maybe you were using Elasticsearch or maybe you're using whatever, there's a lot of different options, right? But the fact that it's all integrated directly and natively into it, it simplifies everything tremendously. I mean, that's the number one thing that I think I've heard from everybody using 3.11 is it really does a great job separating and having that delineation between the operations teams doing what they do, which is making sure the environment is available, stable, secure, and the developers having access to do whatever they need to do unencumbered and not without having to wait for the operations team all the time.
Yeah, so is it fair for me to say, and this is always how I try and summarize, everything up to like 3.9 and 3.7 in OpenShift has been, let's get the developer experience great. Let's get the developers to really have a great experience, to focus on their applications and build. And 3.11, and to a large degree what's coming next, is also adding to the operator, right? Like how do we actually have the operations teams now have more insights and more depth and easier insight into what's happening with those applications, and how can we audit them, how can we control them, those type of things.
Absolutely. I mean, and if you think about it, a developer doesn't want to do what an operations person wants to do, and operations people don't want to do what developers want to do.
Yeah, exactly, right.
I mean,
but so we're sharing this responsibility between our developers, we're giving the developers more responsibility as well, we're giving the operators more responsibility, and they're all just inside of the same single pane of glass, and they all have the same tools, and they can inspect in the same manner. So yeah, that's, I think a fair assumption. So we have about 5 minutes that we can answer any questions that you might have. Is there a roaming mic that, I'll just repeat the question.
So big fan of the OpenShift application runtimes, right? JBoss, PHP, all that stuff you guys provide is secure loving. Question is, in light of the announcement this morning about the AWS marketplace expanding now to include containers, does Red Hat have any plans of taking their application runtimes and making them available in that marketplace?
Oh, right out of the gate, it's a difficult question, right? So the question is, Red Hat offers a bunch of images that using S2I that makes it easy for you to build applications and runtimes through containers. And we launched the container marketplace this morning, or we announced it this morning or last night. And whether those runtimes will be made available in the marketplace, whether Red Hat is actually thinking about that. Right now, there aren't any discussions around it. There aren't any technical limitations for it, but we probably will be discussing it going forward. Again, our common mantra between AWS and Red Hat is if our customers want it, we'll do it, right? This partnership and what we've achieved together with OpenShift has primarily been around what our customers have been asking for. So if you ask us for it, then we'll definitely do it.
Just like auto-scaling groups.
Just like auto-scaling groups.
Just keep hounding us.
Yeah, just ask us, keep asking us, and we'll definitely we'll deliver. Any more questions? Sure.
The Service Broker has a command line interface for those as well?
Yes. Yes, the question is the AWS Service Broker and in the future the AWS Operator. We've shown you the console interface. Is there a way to do it through the CLI or through the manifest files? Absolutely. The resources that get provisioned are native Kubernetes resources using the service catalog, and the the operator framework will be use CRDs. And you can define them inside of your manifest file the same way you manage any other resource in an OpenShift or a Kubernetes cluster. So your infrastructure as code concepts still apply. You don't have to use the console at all. It's just the most visual way for us to communicate what's happening in a demo.
Yeah, we entirely understand that some people don't ever want to see a GUI and vice versa.
Yeah.
Right.
Yeah. Yes.
So AWS has a EKS service. Now we have a OCP, right? So how do we use them? Can we use them in combination together?
Okay. The question is, there's OCP and then there's Amazon Container Services for Kubernetes, also known as EKS. How should you be using them together? The answer is they're actually not the same thing, right? They're quite different in most respects. Kubernetes or Amazon Container Services for Kubernetes, EKS, is honestly just a managed Kubernetes platform. So you still need to go in and deploy things like Prometheus, Grafana, Calico, and all of those type of tools if you want to get the same experience that you get out of OCP out of the box, right? So as a managed service from EKS, we make sure that the control plane for Kubernetes and the control API for Kubernetes is managed, always available and highly available. But anything else, like your automation, your CI/CD, auditing, control, logging, all those type of things, you as a customer need to go and set up manually through manifest files or deploying operators, etc. With the OCP platform, you get that in a prescriptive manner. Red Hat has gone and chosen a prescriptive set of tools that they know work well together. They put their stamp of approval on it. They've given enterprise support to it, and they allow you to basically phone them up and say, listen, something's broken, and help us fix it, and they can fix it. So it's quite a major difference where you have this out-of-the-box experience from OCP as opposed to the managed service where you still need to go and attach all of your services that you want in EKS.
Yeah, and I think one other thing to add to that too is that OpenShift can run anywhere where RHEL can run, right? EKS is specifically and only dedicated towards AWS. And so if you're doing your development environments in your own data center and you want to be able to reproduce those on AWS and you want to use the same type of container platforms, you don't really have that, that opportunity.
We have some really exciting customers where, for example, they have deployments on places that literally leave the continent and then they have internet access while they're on the ocean, and they come back and they sync with AWS over between the two OCP clusters on the ships and the ones in AWS, and they run analytics on AWS at scale, and then they push out the ships again. It's really interesting in how this hybrid economy between these two platforms really come into play.
Good question. How is single sign-on integration for OpenShift?
Are you talking about single sign-on as the concept or single sign-on the AWS service?
Single sign-on specifically for OpenShift.
Okay, so the question is, how does single sign-on work for AWS? For
Active
OpenShift?
Directory, LDAP.
Yeah, it has
OAuth.
Yeah, it has a full IDP controller, so you can actually integrate it with basically anything that supports SAML v2. Yeah,
Yep.
pretty much.
The second question is, I know we're agreeing that, but how is there feature parity between GCP and AWS for OpenShift?
Yes, I mean if you're deploying OCP,
OCP runs the same anywhere.
Yeah.
Oh
no! So no, we have deeper integration with OCP and AWS. Or AWS has an extended alliance that we announced at the Red Hat conference summit 2 years ago, I think in 2016. And we actually have and that alliance is specifically focused on deeper integration with AWS services and the service broker and the operator and those type of tools. Yeah. The quick start.
It does.
It does. It runs on GovCloud, yes. Any
Just
more
recently,
questions?
actually.
So you got OpenShift up and running on AWS. Quick start, you got all that's easy. What does it look like when you need to update? 312 drops, or when you need to update your underlying.
So right now, there are some, I guess, Ansible scripts from previous that you could upgrade. Coming with 4.0, there'll be the operator that will be able to handle upgrades for the cluster. So that's coming, but not there yet.
It's one of those really the expected things that we've been working on. Well, actually, that the OpenShift team has been working on. So to do in-cluster upgrades, in-place cluster upgrades.
Yeah, I think everybody understands right now, just Kubernetes in general, and even OpenShift, it's difficult when it comes to doing upgrades, having to vacate the nodes themselves, making sure that you're moving everything to the appropriate location so that you still have high availability, and then actually doing things in a prescriptive order. Yeah. But that'll all be taken care of in 4.0. So that's part of the Tectonic acquisition, to be honest.
Yeah, the core is. So we have one question, or time for one more question. Do we have one more question? Okay, no one wants to be the last question. You got the last question. Congratulations.
Operators is a good last question.
Yeah, good last question. Thank you very much for taking your time to come up.